So I thought it might be cool to do a short video on a really complex derived state. And so for that, I'm going to show this local anesthesia filter or a feature that I built for the anesthesia charting. And the way that it works is, so you have kind of, what I mean by derived state is you have the kernel of actual state that you're storing. Vitals are due. Got to check vitals. All right. Yep. So you have the actual state that you're storing, for example, the doses of drugs that have been administered, and then you have things that you can derive or infer about that information. So for example, a lot of local anesthetics are given in cartridges, so they track them in cartridges, but obviously depending on the percentage concentration in that cartridge, that may or may not have, that determines how many milligrams of actual drugs are given. But with the input of just cartridges selected, we can actually pick, and also one other bit of context, if you're not familiar with this stuff, which you probably are not, epinephrine, which is basically adrenaline, right, is mixed with a lot of the local anesthetics, basically as a vasoconstrictor, so it will stop stuff from bleeding. And as a result, they have different amounts of epi, but you also don't want to overgive epi, and you don't want to overgive total cumulative. Even if you're using different types of local anesthetic, you care about the cumulative amount that may be in the patient's system at any one time. As it turns out, going from, hey, I used 4 cartridges of this, 3 cartridges of this, to how much does it, is likely to be live in the patient at any one time is extremely difficult to do. Dentists kind of, people that do this kind of stuff, they kind of track it in their head to some degree, but they can only do it to a point, right? So we decided to try to make this easier. So again, derived state. So here is the actual raw drug types that are available, and then we track the variants of them, the half-life of each given drug. Half-life of epinephrine is only 3 minutes. So we turn this into milliseconds. And then, based on that, when they track a dose, we can do this. So I say record dose administer. So I'm going to say this much. And zoom. Something's funny here, the layout. It's on staging. I'll just live with it. But the point is we can actually start tracking live an estimate of total milligrams of drugs given that might be in the system at this time. So as you see here, it's counting down over time, and this is all derived state. So it's derived off the fact that inside of our Redux store, we track application time, which is just current now, essentially. So every second, an idle event gets dispatched. If I turn on debugging here, so if I go store, local storage debug equals true, and I refresh, you'll start to see that every second we actually fire off an app idle event if nothing else has happened. So when we do this, that actually changes the current time in our Redux state. And from that time, combined with what we know about the doses of drugs that were given, we can derive a live, up-to-date half-life estimate of how much drug is in the patient at any one time. And it gets wild. It's one thing, maybe you might be able to pull this off with, like, if you're giving one type of drug, but if you're giving 4% articaine, 4% prilocaine, and then mepivacaine and whatever, and so you're doing this, these are different types of local anesthetics at different concentrations, keeping a cumulative total of this stuff in your head is nearly impossible, right? So by doing this, we can estimate, so now you can see the doses of drugs being administered here. We can see the total amount of local anesthetic that's likely to be in the patient at this moment, based on the individual half-lives of each thing and the times those doses were administered. So do another one. I'm going to do a little trick here. First of all, delete local storage debug, because it gets kind of annoying. And then I'm going to do set speed freak, which is going to speed time up. So now it's going to start cranking here, and vitals are going to be due all the time. It's going to start beeping at us. But what I wanted to show you is here over time, as the time goes, these things start deteriorating quickly, right? And we can add other doses here, and now you see it administered here. Point is, keeping all this math going in your head is practically impossible. I'm going to clear that Speeds freak. That's my little tool that I made for speeding up time. So now several vitals checkpoints have come due already. I don't want it beeping at us. I'm going to complete the latest one here. Okay. But back to the drugs. So how do we do this? So I'm going to go to the code here and show how this works. So you heard me mention Redux Bundler in some of the other videos. This is a bundle. A Redux bundle has a name, has a root reducer, and then it has either action creators that start with do something or selectors that start with select. And these are the things that any component can use to get data or to cause actions to occur. They are also attached to the store itself. So if I go store.do, you can see all the various types of things that you can do or select. So we can do select local anesthetic doses as array. Oh, come on. And so we can see those are the local doses that have been given, the timestamps they were given, the epi concentration of each, the number of cartridges, as well as the milligrams of actual drugs that we calculated that to. And then from that, we can then have other selectors that derive from this. So ultimately, what we have here is select local epi remaining. And you'll note that one of the inputs to this is also app time. So if I go store select local epi remaining, that's what's showing here right now, right? And this is the half-life formula for that, so it calculates a total based on reducing each individual local anesthetic dose and whether or not it has any epi in it. And then this is the half-life formula with the epi half-life, and then we round to 3 decimals. But because this has app time as an input, that means this is going to get reevaluated every time app time changes. So that's why every second it's constantly getting reevaluated here. So anyway, really powerful. You can derive all kinds of complex pieces of information based on the state that you do know. And it's a really powerful tool for, not just, instead of storing like the derived information in your state, you store the basic state kernel and the inputs that you need, and you can derive live information out of those things. And that can be a super useful technique for dealing with complex data. All right.